All right, let's talk about cloud security. If you're studying for a certification or you just really need to get a handle on how to keep things safe in the cloud, you've come to the right place. We're going to break it all down. Okay, let's dive in.
So here's our game plan. We're going to start with the absolute basics. What even is the cloud? From there, we'll get into the single most important concept in this whole field, the shared responsibility model. Then we'll walk through 6 pillars of protection, do a deep dive on identity, and wrap up with how you actually secure your digital space.
All right, first things first. What exactly are we talking about when we say the cloud? Before we can even think about securing it, we have to agree on what it is. We need a solid, official definition so we're all starting from the same page.
We throw this term around constantly, right? But what does it really mean, technically? What's the difference between a server in a closet and a service that is truly cloud? Let's find out.
Well, the folks at the National Institute of Standards and Technology, or NIST, gave us the official definition. Now, there's a lot of words there, but the key ideas are on demand and a shared pool of resources. That shared part is what makes the cloud so incredibly powerful and efficient, but it's also exactly why security gets so complicated and is so absolutely critical.
So according to NIST, for something to be a true cloud service, it has to have these 5 things. First, on-demand self-service. Think of it like a vending machine for servers. You get what you need without having to ask anyone. Then there's broad network access, which just means you can get to it from your laptop, your phone, wherever. Resource pooling is key. You're sharing the underlying hardware with other people, which is how it stays cheap. Rapid elasticity is the cool part. It can stretch and shrink almost instantly to meet demand. And finally, measured service, which means you only pay for what you use, kind of like a utility bill.
Okay, and you'll see the cloud delivered in 3 main flavors. Think of it like pizza. Infrastructure as a service, or IaaS, is like getting the raw ingredients, the flour, the cheese, the sauce. You get the building blocks, but you're responsible for everything from the operating system on up. Platform as a service, or PaaS, is like they give you the pizza dough and the oven is preheated. You just focus on the toppings, your application. And then there's software as a service, or SaaS. That's just ordering a pizza. Everything's done for you. The key takeaway? As you move from left to right, you manage less, but you also cede control, and that directly impacts your security responsibilities.
And that idea of responsibility leads us right into what is, without a doubt, the single most important concept in all of cloud security. Seriously, if you remember one thing today, make it this: the shared responsibility model.
This is the big question, right? When something goes wrong and there's a breach, who's on the hook? Is it the cloud provider's fault? Is it on you? Well, the answer is, it depends. And it all comes down to understanding something called the trust boundary.
And this chart illustrates that boundary perfectly. See that black line? That's the dividing line. For IaaS, the provider secures the physical stuff, but you are responsible for securing everything from the operating system up. A huge mistake people make is thinking the provider patches the OS for them. They don't. When you move to PaaS, that line moves up. The provider takes care of the OS. And in SaaS, they handle almost everything. Your job shrinks down to managing user access and your data.
Let's look at it one more way, with this tech stack. Everything below that line, the physical building, the servers, the network, that's the provider's job. They are responsible for the security of the cloud. Everything above that line is your problem. You are responsible for security in the cloud. Getting this division right is the absolute bedrock of any good cloud security plan. So it's pretty clear you have a big job to do on your side of that line. So now let's talk about how to do it. We're going to break down your responsibilities into 6 key pillars of protection. These 6 areas are basically your security checklist. You have to think about identity, who gets in. You have to secure the network in each individual computer or instance. Of course, you have to protect the data itself, design a secure application architecture, and never, ever forget patch management. We're going to focus in on a couple of these, starting with the big one, what many now call the news security perimeter. And that, of course, is identity. Think about it. When your servers aren't locked in your own data center anymore, the main thing stopping someone from getting to your stuff is proving who they are. So who gets the keys to the kingdom? Well, you really have 2 groups of people to worry about. First, you have your end users, your customers. For them, the goal is a smooth, simple login. You can't ask them to remember 50 different passwords. The solution there is single sign-on, or SSO. Then you have your own team, your engineers and admins who need to get into the cloud console. For them, the challenge is different. It's about giving them just enough access to do their jobs and absolutely nothing more. That's where Identity and Access Management, or IAM, comes into play.
So the magic that makes most corporate SSO work is a standard called SAML.
You can think of it as a three-way digital handshake. There are three players. The principal, that's just you, the user. The identity provider, or IDP, that's the trusted system that knows who you are. And the service provider, or SP, which is the app you're trying to get in.
Okay, so let's walk through this because it's pretty slick. You try to log into Salesforce. Salesforce has no idea who you are, so it sends you over to your company's identity provider. You log in there just once. The IDP then sends a secure, digitally signed note back to Salesforce. That note, called a SAML assertion, basically says, hey, I've checked this person out, they're legit. Salesforce trusts that note and lets you write in. And the best part? No separate password for Salesforce needed. It's clean, it's secure.
All right, identity is handled. We know who can get in. But what about the digital roads they travel on to get there? And what about the security of the virtual servers themselves? That's all about network and instance protection.
So, to protect your data while it's in motion, you've got a few choices. A private connection is like having your own private, dedicated highway straight to the cloud. Super fast, super secure, but also super expensive. A VPN is more common. That's like putting your data in an armored car that drives on the public internet. And internally, cloud providers use VLANs. Think of these as virtual walls inside a giant warehouse, keeping one customer's stuff separate from another, even though it's all in the same building. But here's the thing about those virtual walls. They aren't made of concrete. They're a logical separation on shared hardware. And that means if an attacker is clever enough, that separation can be broken.
This kind of attack is called VLAN hopping, and it's exactly what it sounds like. It's a way for an attacker to effectively hop over that virtual fence and start snooping on traffic that should be completely invisible to them. It's a huge problem because it breaks that fundamental tenet, isolation.
Now, attackers have a couple of tricks to do this. They can try to fool the network equipment into thinking they're another switch, or they can craft these tricky data packets with extra labels to confuse the system. Now, don't panic. The big cloud providers have very strong defenses against this, but it proves a super important point. You can never, ever just trust the network. You have to secure your own stuff.
And that's where the idea of defense in depth becomes so important. You need layers of security on every single virtual machine. A host-based firewall is like a personal bouncer for that one server. For your web apps, a web application firewall, or WAF, is like a specialized guard who knows all the common hacker tricks and stops them at the door. A host IDS is like a security camera watching for any shady behavior on the machine. And integrity checking is like having a checklist of every file and constantly making sure nothing has been changed without permission.
And all of this brings us to one final big idea. You know, the old way of thinking about security was like a castle with a moat, a really tough outer shell, but once you were inside, you were trusted. In the cloud, that castle, that perimeter, it's just gone. Your data is everywhere, your users are everywhere. So it really makes you think, is rigorously proving and managing who someone is identity, the new and maybe the only true firewall we have left? That's the question every one of us in this field has to wrestle.